like Alex was saying, my name's Chris. I work over at CHEMOURS. We make the refrigerant. We make this Opteon, these Opteon products. So XL41, the R-454B, and there's some other products that are coming out. The manufacturers all have to switch over to either 454B or R32, and we make the 454B. We also make 32, so you might see our stuff on your shelves for both of those. Okay, so table of contents, some of the stuff we wanted to go over tonight, just terminology. There's a lot of new terminology out there regarding these new refrigerants, just because it's not something we've been dealing with before. So I just want to go over that. If y'all have any questions, maybe they're on here. If it's not on here, just like I said, shout it out. Go over a little bit of regulations and codes. Why are we making these change? Why is the industry changing? We'll talk a little bit about A2L refrigerants. Yeah, basic safety stuff. What makes it an A2L? That kind of thing. Flammability. What do we, what are all the details in there? We'll talk about overview of XL41. Why are so many people selecting XL41? Like, what's the big deal? Why that one? Why not, why not 32? And then we'll also talk about XL41 in use, right? Stuff that your contractors need to know when they're using it. Just put it and throw it in the back of their truck, that kind of stuff, having it out on the jobs. And obviously at the end, we're gonna have time for questions and answers. So pretty standard little set of information, but if you guys have questions along the way, please stop and ask. Okay, y'all are ready? Let's dance. Okay, common terminology. HFO. If you guys see HFO anywhere, this is where it lands, right? It's so we've been calling refrigerants HCFCs, HFCs, hydrocarbons, and now we've got HFO. So it's this new type of molecule. Okay, the molecule has something funny about it, and it's called a hydrofluoroolefin. And we'll talk a little bit more about it. We've got a little picture. It shows you what the olefin part means. But essentially, HFO means hydrofluoroolefin. It's like a refrigerant of the future. It's the next type of refrigerant. So when you see HFO, that's the family it lives in, right? Okay. Now XL41 is something called an HFO blend. It's got an HFO and R32. So it's got an HFO in there. You'll also might hear them called an HFO blend. But that's the idea with that. Okay. ODP, you'll see that sometimes. That's ozone depletion potential. And that's something that was a big problem with R22, which is why we went from R22 or R12. We moved away from those and went into R410A. That's all about ozone depletion potential. And GWP is the new one, right? It's the global warming potential. So we'll talk a little bit about that more later on, but GWP, that's what it stands for, global warming potential. And that's what's making the news kind of all over the place. The AIM Act is the American Innovation and Manufacturing Act, and that's something that the government put into policy, and it gives the EPA the authority to make these rules and make these changes. So the AIM Act is the law that's enacting all of these changes. The EPA is the Environmental Protection Agency. They're the ones who are able to kind of do this. They've been given authority to make the rules. CARB, you guys don't really need to worry about that. That's over in California. SNAP is a significant new alternatives policy, and that's kind of an interesting one right now. If you guys deal with commercial refrigeration at all, SNAP rule, there's a SNAP rule that's coming out that's going to impact that. Do you guys do any commercial stuff, like commercial refrigeration, or is it mostly HVAC?
Mostly HVAC, some commercial refrigeration.
Okay, sounds good. So, what's that?
80-20.
80-20? All right, yeah. Super cool. So SNAP Rule 26 is about to get signed. It'll get signed this month, and that allows for 454A and 454C to be used in commercial applications. So at this time, they're not able to, but as soon as that's signed, then it's then we're going to have our big ABC promotion. You're going to see 454A, 454B, and 454C being promoted by us. But it's a SNAP rule. It's when the government says, yeah, you can use this refrigerant for that application. So that's SNAP. And then another thing you're going to see a lot in this coming up in conversation, right, is the CO2 equivalent. And that's related to GWP up at the top, but it's it's different. It applies to us, and some of the information that we're going to go over, you're going to see why there's a difference. But essentially, they're used kind of similar. They're kind of similarly. AHRI is the Air Conditioning and Heating Refrigeration Institute. They actually do a lot of cool studies and a lot of good training. NFPA is the National Fire Protection Agency, and they've done a lot of work studying this stuff when we talk about flammability. And then also the ASTM, right? The Society for Testing Materials. So those are the folks who have been running all the tests, trying to determine flammability. What are the parameters and where does this stuff land? So you might see some of those. Some of the terms that you use. Oh, I can't see that bottom one. It's blocked by the thing. LFL is the lower flammability limit, and that's an important one. That you're going to see that come up more and more often, just about as common as GWP is going to be that LFL if you're not already seeing it. That's the minimum amount of refrigerant that you need to have in a space in order to get a flame. If you don't have the lower flammability limit, if you don't have enough, you'll never catch a flame. So it's the least amount that you need in order to get a flame. So that comes up quite a bit because that's really a safety issue. And then MIE is the minimum ignition energy. And the honestly, the subtitles are blocking the last one, but I think we're okay. Alrighty. Are there any questions about the terminology? Because we can add some if there's something that you've heard that you don't have a definition for, anything like that.
No, so far.
Okay. Alrighty. Why is it all happening? That's the big question. And a lot of folks in the US, especially in the HVAC industry, aren't aware of this. But what's going on is we used to have this thing on the left, ozone depletion potential, right? That's back when we had R22 and it switched over to 410A, right? And now we've got this global warming potential that we're looking at. Science has changed, science has improved, and we've been noticing that the globe has been warming up, right? So they're trying to figure out what's doing it. Refrigerants fall in there somewhere, HFCs specifically. Now, HFCs, they're not just refrigerants. It's also the foam blowing agents, propellants, fire extinguisher stuff. So it's the HFCs are kind of found throughout the industry, but what they found is they don't break down in the environment. And when they get into the atmosphere, it kind of traps some heat in like a blanket. So that being the problem, let's see. Originally, there was the Montreal Protocol. And the Montreal Protocol, this is all done by the UN. So this is like 197 countries get together and they sign this stuff. And that was where they signed the Montreal Protocol. And the Montreal Protocol phased out anything with an ODP in it. Okay. So that's a big protocol, a big piece of paper. What they did recently is they had the Kigali Amendment, and that's in 2016. And so the UN, all 197 countries got together and they all signed a piece of paper saying, we agree we should ramp down the production of HFCs, or at least the production of dangerous HFCs. Okay, so them signing that piece of paper is one thing. Them going back to their home country and calling it law is something completely different. And so although everybody signed it in 2016, it took a long time for everybody to start ratifying it. Well, when we ratified it here in the United States, it was in the end of 2020. The president signed it into law, and what he signed was the AIM Act. So the AIM Act is the U.S. ratifying or making law the Kigali Amendment that was signed in the UN. So this isn't just a U.S. thing. This is like a global thing. This is a global movement to ramp down HFCs everywhere, not just the refrigerants, right? So anyway, so we're going from our 410A, which has a GWP of over 2,000, and we're starting to see GWPs lower than that, right? So 454B has a GWP of 466, and R32 has one of 675. So when the US adopted the Kigali Amendment and ratified it in the AIM Act, that's when the EPA was given the authority to drop down our limitation, drop it down. And so that's why we're moving to these lower GWPs. Let's see, we talked about that. That's the international level. Originally, what happened is we were talking about that, right? So in 2016, the globe signed the Kigali Amendment, right? Everybody signed it. But we had a brand new president, and the brand new president wasn't interested in global issues to that degree, right? He was more focused on national issues, and so he didn't want to sign a global movement. He wanted to do what was right for the country. So what happened is in the U.S., several states, 24 states, they all formed the Climate Alliance, and what those 24 states did is they started passing their own laws that loosely mirrored the Kigali Amendment. They started doing their own version of the Kigali Amendment, but what happened is that caused so many problems with manufacturers like Rheem, Train, all those guys. What they had to do is they pushed for the federal government to sign it. And so the federal government signed it in 2020 and created the AIM Act, and they gave the EPA the authority to start working on it. So that's the kind of the flow with the regulations. Up till now, the EPA has been tasked with doing 3 different things, and they've done 2 of them. Okay. The first thing they did is they set up an allocation program, and there's a chart, there's a step down chart, and you may have seen it, but that's really for us. That's for CHEMOURS manufacturers. That's and for people who are importing into the US, right? The refrigerants. It is not about any one refrigerant. It's not about a certain weight of refrigerants. It has to do with that CO2 limitation. Okay. Also, they were tasked with doing a technology transition. They were tasked with telling the industry what the new GWP limits are going to be. For instance, in air conditioning, the GWP, after January 1, 2025, the GWP needs to be below 700. So that's something that they were able to come out and say, right? They're able to say, okay, guys, it's official, January 1, 700 GWP. For commercial refrigeration, it's down around 300 or less. And then if you've got a really large system like a supermarket with, over 200 pounds, but that's really around 1,000 pounds or so, then that needs to have a GWP of under 150. So that's all EPA dictated. That's the technology transition rule that they came out with. And now that bottom one right there is refrigerant management programs. That's the third thing that they have to do. Right now, they're in the middle of writing it. And at some point, I think it's this year, they're going to sign it and finalize it. And what that means is that they are going to have refrigerant reclaim laws. They're going to put into effect laws and I guess laws and guidelines of how much refrigerant needs to be reclaimed from the industry. And really, that's going to be a new thing for the US. It's going to be a new thing for you guys. You're going to have to deal with it. Maybe you're not doing anything with it now, but by the end of this decade, 2028 or so, it's going to be a big deal. So I would say look for more information on that. But that should be signed and finalized at the end of this year. It'll come into effect later on. This is a little chart that I like to show. The blue step down in the background, that's that first thing we were talking about, right? The allocation program, that's for us. That's for companies like us. We have to decide what refrigerants we're going to sell and put into the market because we're only allowed so much CO2 equivalent. Think of it like we have a CO2 equivalent bank, and some stuff like 410A takes out 2,000, while a pound of 410A would take out 2,000. A pound of 454B would take out 466. Okay, so we have only so much equivalent in that account, in that bank account, and so we have to sell products into the market that allow us to. We're only allowed so much CO2 equivalent, so we need to do what's best for our business. You know what I mean? If we sell stuff that's got really high allocation, really high GWPs, then we're going to blow through that allocation that we have very quickly. So we're not going to make very much money. If we want to make more money, if we want to make the same amount, then we have to sell low GWP stuff, essentially. Anyway, so this is that step down. You'll see this. We did the first step down. Sorry, the timeline's blocked by the subtitles. But the first step down that you see here from 100 to 90, that was in 2022. So we're already underway with it. But this bigger step down happened just January 1 of 2024. And so this allocation that everybody has is going to stay out until 2028, where it's going to drop down again. So that's the step down for the allocation that has to do with the manufacturers. Now, the technology transition in red, where it drops down, if you look at 410A, their GWP is 2,088. But just by dropping down to 454B, it drops down to 466. That drops down to 22%. So just by Ream, Train, all those guys transitioning to a lower GWP, they've matched the phase down. You know what I mean? So the two are actually working together for the first half of this decade. The switch down, everybody has to use a different refrigerant, and our allocation reduces. That makes sense. But now when you get over to 2028 out through 2033, that's when your refrigerant management programs are going to come into play. And that's where people are pulling the refrigerant out, selling it back to places like Hudson or A-Gas or wherever. And A-Gas is cleaning it up and selling it back into the industry, right? So companies like Train are going to have in their system when they sell it out to the market, like 15% of that has to be reclaimed, right? So it's taking a lot of refrigerant from that's already in existing equipment now, cleaning it up, doing something with it, and selling it back into the industry. And that's going to help us kind of keep bringing down the amount of refrigerant of CO2 equivalent that's being sold into the market. So the three things that we talked about, these three right here, this is kind of how they all work together. Any questions about that stuff? I don't know if I explained it right or well at all, but that's kind of what I got for that stuff.
No. Right now, I think we're good.
All right, regulations. Gotta love them. California Resources Board. Okay, so in order to make all these changes, this is kind of where we're at. The first thing that needed to happen was all the standards like UL 2-40 and ASH rate 15.2. Those standards all needed to change and adopt A2L refrigerants, and they did. That's done. That happened a couple of years ago. And then 2022, 2023, everyone was working on these model codes, trying to get IMC, UMC, everybody updated to be able to permit A2L refrigerants. And all of that work has been done. So now all the building codes, one way or another, I don't know what's used over in Florida, if it's a state code or a local code, but essentially Florida's already set. Florida has adopted either laws that allow A2L refrigerants, or they've adopted 2024 model codes that allow for A2L refrigerants. Okay, so that was a big battle that was fought for a couple of years, but that's all set now. So now it comes down to the state codes, and we're all set, right? And it's that bottom part right now that you're seeing, the local codes. And this is where it gets kind of fun, right? So distributors and so warehouses, if you have any large contractors that warehouse some of the refrigerants or whatever you guys have in your branches, a local fire marshal is going to need to approve you having a certain amount of A2L refrigerants. Because up until now, everybody's fire codes, up before 2024, the model codes, everybody's fire code said it's either flammable or it's not, right? But the 2024 version of NFPA1, the fire model codes, now the 2024 versions say, okay, yeah, A2Ls are okay. You can do up to 10,000, 20,000 pounds, not a problem. But before 2024, the limit is like 600 pounds, which is not even a full pallet of this stuff. So right now, when it comes to distributors and large contractors who warehouse it, you're gonna need to have a local fire marshal come and approve that the storage of more than 600 pounds. You know what I mean?
I have a question for you.
Yes.
I know that for the new building codes, they're needing to do fire shafts in the middle of the buildings to run the copper lines through in case of a fire hazard if there's a leak. That's part of the building codes now here in Miami, and they're redesigning all the buildings, and that's delayed construction a little bit. What are they going to do for the or do you know if they're going to do any changes to using this refrigerant on existing buildings for retrofits?
So you're not going to retrofit a piece of equipment. So, but what you can do a lot of times, so like if you have a 410A system, you're pulling it out.
I'm saying a building. I'm saying a building, like that's happening a lot now in Miami Beach. They're getting older buildings, and to put them up to codes, up to the new standards and everything, they have to put impact windows, they have to change out all the ACs and do everything. But all these buildings, the structure of it doesn't have a fire shaft space for the new copper lines to run this refrigerant like the new construction is. Do you know anything that's gonna happen with existing structures that are getting remodeled with this new refrigerant?
No, when it comes to commercial stuff like that, I'm not sure. I can ask that question in and get you an answer back though.
Yeah.
Okay, so you're in Miami. And those are pretty much commercial buildings, right? That's a group of
Yeah, it's
apartments or multi-tenant.
multi-families and apartments and hotels and stuff like that that are getting retrofitted. And I know all the new construction high rises, they all have to have this fire shafts, and all the engineers are redesigning everything. And construction's kind of been halted this year because of the new gas. So I'm just asking because contractors are asking me if existing buildings, what are they gonna do for like a fire shaft? When they have to redo the HVAC side in an existing building, there's no space for it.
Yeah.
It wasn't built around that. So what are they gonna, like, what kind of solutions or what alternatives are they coming up with? That is a question I'm getting.
Yeah, you got it. Okay. So let me talk to the guys tomorrow, see what kind of an answer I can get for you. What's your name, sir?
Isaac Aram.
Isaac?
Yep.
Okay, if I sent this over to Alex, he'd be able to get it to you?
Yes, perfect. That'll work.
Okay.
And he needs to know about it as well. So
Okay, super cool. All right, all right. All right, let's move on to the fun stuff. A2L, if you guys don't know, A2L falls into this table, right? So it means if you've never seen this table before, in the top right hand corner, the A column, right, means lower toxicity. It means it's not going to poison you. If you get exposed to this, you're not gonna get poisoned from it. But if there's too much of it, it might block out the oxygen that you need. But essentially, you're not going to die because you got poisoned. But if you were over in the B group there, that's higher toxicity. That's going to be like ammonia, any kind of gases that are toxic that you would need a mask for. So there's those two different safety categories. And then when you go top to bottom, that's all flammability. Okay, so 1 means no flame propagation. And everything burns under the right conditions, but no flame propagation basically means if you were to get a flame, it wouldn't continue, right? So if you got a flame, it would burn itself out real quick, that kind of thing. Lower flammability is just a hair above that. And we got some pictures. We'll show you what that means as far as flammability. Then above that, you've got A2, which is more flammable, and then 3s, right? Higher flammability. And the A3s are a lot of the hydrocarbons, right? So propane, butane, that kind of thing. So flammability really goes from not being able to sustain a flame to take your eyebrows off, right? And so this stuff is really close to the lower end of the spectrum, and we'll take a look at that. But if you ever do hear A2L, that's what this is coming from, and this is from ASHRAE 34. This is just a table that they have put out, and they group all of the refrigerants that they approve. They group them, they give them a safety group, anything from A1 to B3 in there somewhere. But essentially, that's where this comes from if you see A2L. We thought it needed some color, so we added some color. Propane. So a lot of folks actually ask us, they say, does XL41 or R-454B, does that have propane in it? And the thing is, no, it doesn't have propane in it. And it just doesn't. It has R32 and 1234YF, which is that HFO we were talking about. And we'll talk a little bit about that more. But we do compare it to R290, which is propane, in this chart, just so people can kind of see how big of a difference there is. Alrighty. What you're going to see on here is for 410A, it has a GWP of 2088. And the composition of 410A is 50% R32 and 50% 125. And 125 has a GWP of 3,500, right? It's really bad for the environment if you're looking at GWP. Actually, it's a fire retardant. They put it in fire extinguishers because it does not react with oxygen. Okay, you can spray it on oxygen. It's not going to do anything. It'll remove the oxygen, but it's not going to burn. It'll actually put flames out. So that 125 puts flames out, but it's also bad for the environment. So what they did is they pulled that stuff out and they put in a little bit of this 1234YF. The ratio changed a little bit. So now the 454B is 69% R32 and 31% 1234YF. What they did is they pulled out the part that keeps the flame from growing, right? 32 is an A2L. It's always been flammable. So R32 is an A2L. And what they've added in is they've added in another A2L rated refrigerant, that 1234YF. Now these do react with oxygen, which means they burn, right? But because they react with oxygen, they break down in the atmosphere, which makes them good, makes them not very bad for global warming, right? You want refrigerants that break down in the atmosphere so that it doesn't become this gas that makes a blanket. So by reducing the GWP, by making it more reactive with oxygen so it breaks down, you've actually made it reactive with oxygen, so now it burns. So that's kind of the trade-off that you get. When you reduce the GWP, generally you're increasing your flammability. So you'll see that as we go through with these new products. A lot of times the lower the GWP, flammability does go up into A2L range. Okay, we talked a little bit about ASTM. That's a scientific organization, and they ran a test. They figured out there's this test. They took like a chemistry beaker, like you'll see right there, there's a little diagram. They feed in some air from the top, and then they feed in refrigerant also, and they mix it, right? So you get the right mixture in there, and then they have a little electrode right in the center that causes a spark. And so they measure a couple things with this. They measure how much refrigerant you need in order to get a spark and get a flame, the LFL we were talking about, but then also how much power do you need to generate a spark? How hot does that spark need to be? Okay. So if you're looking at a class 1 flammability, this is 410A. So that's what it looks like, right? It will burn. You give it the right conditions, it is going to burn, but it stays within that 90-degree mark, right? So it stays within that 90-degree mark. If you look at the flame, it doesn't have a whole lot of energy to it, right? So it's considered a 1. That's just how they scored it, okay? If it extends past that 90-degree mark, it's flammable. Okay. So this is what a 2L is. 2L has a little bit more energy to it, and it just barely crosses over that 90-degree mark. Okay, so it does burn, but it's still pretty lazy. It's not something terrible. The fire guys are not worried about this one at all. Okay, so it stays just outside that 90 inches, therefore it's considered flammable, but a 2L classification, I don't know if you guys know, but for it to be rated as a 2L, it needs to burn slower than 10 centimeters per second. Okay, 10 centimeters, that's about 5 inches per second. So if you move your hand 5 inches in a second, that's a pretty slow flame. Okay. Now, this is a class 3, right? Again, we're just talking about a science beaker, and what they did is they put some propane in there, and they ignited it, and it popped the top off, right? So you get a big reaction in there. So there's really a world of difference between when it comes to flammability between a class 1, a class A2L, and then a class 3. Okay, so when we do talk about flammability, yeah, but it's not like you're expecting. It's not like the gas grill going whoa and you losing your eyebrows. It's not like that. But essentially, that's what we got there. Now, parameters. This is we do have some slides here, and I like to do a little bit of a reality check on them, so it kind of makes it relatable, a little bit understandable. This is going to compare, again, we're looking at 454B and 290, but we're talking about some of the characteristics of flammability. What makes it flammable? What are the different aspects of it? Lower flammability limit. Now, the higher the lower flammability limit, the lower the risk. So with this one, this is telling you that it needs 297 grams per cubic meter in order to get a flame. Okay. With propane, you just need 38. When I saw that, I'm like, what does that mean, right? What that means is if you made a box in front of you, right, that's about 40 inches wide, 40 inches deep, 40 inches tall, you would need 10.5 ounces of refrigerant dumped into that space before you can get a flame. So 10.5 ounces going in there, that's 3/4 of a pound, right? That's a lot of refrigerant into that little space, 40 inches, 40 inches, 40 inches, in order to be able to even get a flame. Now, as opposed to propane, you would just need a shot glass, right? That's 1.5 ounces, 38 grams. That's a very small amount. but you can kind of, you get it now, right? If you know, 10.5 ounces, almost a full soda can, when are you going to see that kind of volume in an air handler? You know what I mean? Like that's a lot of refrigerant. So lower flammability limit means you need a lot more refrigerant in the space in order to even get a flame. So that's what LFL is all about. When we step down to minimum ignition energy, that's how hot of a spark do you need, or how hot of a source, ignition source do you need? Now, this really just talks about sparks. It doesn't talk about the temperature of like of a thing, right? But this one says 100 to 300 millijoules versus a quarter of a millijoule. Now, a quarter of a millijoule, if you were to scuff your feet, I don't know if it works in Florida at all, but static electricity, right? So if you scuffed your feet and you touch the doorknob, the spark that you get is about a quarter of a millijoule, right? It's hot enough. You can light propane with that. There's YouTube videos. You can watch crazy heads do stuff, but you can light propane with static electricity. Now, as opposed to 100 to 300 millijoules, which is like a performance car spark plug, like a Mustang Shelby spark plug, you would need a very hard, big spark in order to get that. You're not going to get that kind of a spark from like a power drill, a cordless drill. You're not going to get that. If you're unplugging or plugging in any kind of vacuum pump at an outlet, you're never going to create the spark that reaches this size. So you actually need a lot more energy in order to ignite an A2L. Now that has to do with the sparks, right? But as far as temperature goes, you need 700 degrees Celsius. So if you're talking about a hot piece of metal, you're never going to get 700 degrees Celsius out of that. It'll start dripping, right? It'll sag, whatever you got the hot, because that's about 1200 to 1300 degrees Fahrenheit. That is a very hot piece of metal. Now, your cigarette lighter is 1000 degrees Celsius. So an open flame will ignite an A2L. So really that's where you're going to find it, right? You're going to find your issue, your danger with an open flame. Your cigarette is not going to be hot enough. If you have a guy smoking and he opens up the air handler and he sticks his head in there and it's full of refrigerant, it's going to put his cigarette out. His cigarette does not burn at 700 degrees Celsius. But if he were to open up the air handler and stick a cigarette lighter in there to look around, he would ignite it, right? So that's kind of where we're talking about as far as being able to ignite the stuff. You need a very high spark, or you need an open flame. Now, burning velocity. We did talk a bit about this. 454B burns at 5 centimeters per second, so half of what you need to be an A2L. So it burns at about 2.5 inches per second. Very, very, very slow. And propane burns at 46 centimeters per second, which is about 18 inches, right? When I move my hand 18 inches in a second, I can almost hear the propane going, whoa, right? You know what that sounds like. You know how it hits your skin. But if I have a flame coming at me that's 5 centimeters per second, I'm not terribly worried about that one. So all of this to say, yes, it's flammable, but so is your shirt. You know what I mean? So is your notebook. Like we're not really talking about a major hazard, but be aware that it is flammable. So you know what I mean? Now heated combustion is the last part that I like to talk about. And that has to do with how hot is the flame, right? If you were to burn a piece of paper, it would definitely burn from top to bottom. Sorry, bottom to top, right? That'd burn straight up. It burns hot enough to ignite the unburnt piece of paper, right? That's how the flame would travel. But if you were to burn like a piece of masonite, right? The flame, you could get it on fire, but the flame may not be hot enough to ignite the unburnt piece of masonite. You know what I mean? It would just burn itself out. It doesn't burn hot enough to keep the flame going. And that's what we found with A2Ls. With they're burning, the heat of combustion is so low. Oftentimes, when you remove the open flame or you remove the hazard, the ignition, it just burns itself out. It doesn't burn hot enough to keep the flame going. Essentially, though, propane burns 4 times hotter. So I think everybody knows what propane feels like on that kind of a flame. This is, a quarter of that temperature. That's the boundaries around flammability, friends. Any questions about flammability?
No.
I have a question.
Yes, sir.
When the technician is welding, is gonna be a hazard in there?
Welding?
Yeah.
Welding, yeah, I mean, it's going to be an issue. That's why best practice is to evacuate your system out, right? So if you're brazing on, if you're trying to remove a coil, you're going to want to evacuate the system. You're going to want to pull it out so that there's no refrigerant in there anyway. But then when you are brazing the joint to remove the coil and you break through that solder, if there's some pressure in there, it'll probably blow some oil out. And that oil is really what you're going to see. That oil flame is going to be what you see. But best practice is to purge it to get all that refrigerant out of there. So you're not going to want to be torching anything that has a flammable refrigerant in any way, because you wouldn't do that with a 410A system anyway. You know what I mean?
Well, maybe here in Miami they would.
What's that?
Maybe in Miami they would. There's a lot of crazy people out here.
There's always little Johnny, and little Johnny scares the hell out of me because he goes from school to the attic where he's surrounded by dry pine and he's got a torch. And I'm like, bro, refrigerant is not your problem. Little Johnny's your problem, man. You got to sort him out.
You don't think the gas, and I know that here in Florida, there's leaks every once in a while in the attics because the copper lines run through the attics. You don't think if there's a leak up there and the unit leaks out all the gas and they get up there and weld it, you don't think that'll blow, no?
No, I don't. And here's why. So the equipment that we've been using for years, and you guys are going to see more about this. I forget, what kind of equipment do you guys sell? What kind of residential stuff?
Residential AC units.
Yeah, like Rheem.
Yeah.
Okay.
Rheem, Comfort Star.
Okay, super cool. So all of the stuff that Rheem and Comfort Star has been selling now with 410, you guys know exactly how it works, right? There's no big deal. The only reason that blower turns on is because it gets a signal to turn on, right? But in the future, the equipment that has 454B in there, there's going to have 4 different refrigerant sniffing sensors inside the air handler. And as soon as it starts to smell refrigerant in there, 20% of the LFL, we talked about that, right? As soon as it starts to smell refrigerant, it's going to kill the compressor and it's going to turn on the blower and it's going to blow air through that air handler. So you never get that concentration, that flammable concentration. So that's inside the air handler, right? And that's where it's a confined space where you might get a flammable volume. You know what I mean? But outside of that air handler, if it's just leaking into the ceiling or attic space or stuff like that, you need so much refrigerant to get a flame that it's very hard to actually get that amount. I stay in hotel rooms a lot, and a hotel room is about 300 square feet. And if you do the math based on the grams per cubic meter, stuff like that, you would need, we have 20-pound cylinders of this stuff. You would need 43 pounds of refrigerant dumped into that hotel room in order to even get a flame. So if I took 2 of those DACs, hit them with a hammer inside that hotel room, and filled it with that refrigerant, 40 pounds of refrigerant, I still would not have enough refrigerant to get a flame going.
Okay, that explains.
So it's really hard to get a concentration of stuff. Could you get it in an air handler? Yeah, you might get 6 pounds into an air handler. That you could, but into an attic space, this is a non-issue. You know what I mean?
Yeah.
Yeah, it's real hard to do.
Smell, odor, smell.
It's about the same as 410A, right? So it's got like a real soft, like kind of pleasant smell. It's a little floral, that kind of thing. That's what the SDS says. I don't huff it. I don't like open it up and I don't do that.
Wait, we all look at each other like, oh.
When I'm alone,
Yeah.
But no, the SDS says the same thing for 410A as it does for this stuff. So it's not that bad. All right. Industry testing. So these guys, who are these guys? This is the Firefighters Safety Research Industry, right? So the FSRI, they did a test. They did some tests. This is what they found. The testers supported the notion that the primary hazards associated with refrigerants are flammability and toxicity byproducts of combustion. These hazards are very similar to both A1 and A2L refrigerants. Essentially, what you're getting with 410A is what you're going to get with an A2L. One of the studies that they came out with, wasn't formal, but it's kind of what they were saying, is if you were to throw 6 to 8 pounds of 454B into a structure fire, it would be the equivalent of throwing a 2x6 into the structure fire. It's really not that big of a deal, right? So it's not going to burn so hot that the firefighters are going to stay away from the building. The firefighters are still going to run in, no issue. Yes, it catches on fire, but it's like 410A. It's nothing that they're not used to already.
Gotcha.
About transport.
Transporting it. What about it, sir? I've got lots of information.
Are they gonna require some placard or something?
No, sir. Nope. So a technician driving around town, he's still going to have the same limit of 440 pounds, just like on a regular A1, right? So he can have 20 cylinders of the stuff in the back of his truck, and that's not an issue. If he has more than that, then it's no longer materials of trade. Now he's transporting products, and that's when he's going to need a placard. But for the most part, Johnny in a truck, no issue. But if you are sending a truck out to a contractor and you've got, I guess 22, 23 cylinders in the back of your truck, you're going to need a placard. But it's a lot. So, so transportation, no real change. The Department of Transportation has been dealing with nasty chemicals forever. For instance, every truck has an acetylene torch in there. You know what I mean? So the Department of Transportation has been dealing with flammable materials as materials of trade for a super long time. Nothing new here. That's the easy answer for guys in the truck. We'll talk a little bit more about it later on, but the way the laws are written now, flammable gases need to be transported standing up. Right. So if you keep it in the box, you keep the box standing up, head on down the road, that kind of thing. But what a lot of guys do is they toss the cylinder into the back of the truck and it's laying down or it's in a rack. Right. In general, A2Ls need to be transported standing up. But CHEMOURS went to the Department of Transportation and we got a special permit. So on our cylinders, there's going to be a special permit number where it says that you can transport it laying down. You can transport it in your racks. You can transport it horizontally. So that's a special permit number. That's something that CHEMOURS is doing. Honeywell doesn't have that. A-Gas, and nobody else has these things, has that special permit, just us. So if you're selling our product, you can say, yeah, you can toss it in your rack, no problem.
So you buy that refrigerant from another brand, are you gonna be able to use that permit as well?
No, it would have to have that special permit number on the cylinder.
Got it. Thank you.
Yep. And that's when the refrigerant police pull you over and have you dump your truck and inspect you, which, yeah, I don't know the last time that happened, but if it ever does happen, there'll be a special permit number on the cylinder.
The $100 bill save me from that?
And that cylinder never gets scratched up or scuffed or anything, so it's gonna be great. No, it's not gonna be a problem though. A lot of what we're trying to make sure people are knowing, and I'm glad you guys are asking questions, but the working with 454B is so similar to working with 410A that your technicians are really not going to see too much of a difference. You know what I mean? Their best practices. Oh, let's go to that. Best practices are now going to be required, right? So like Ream is going to say, hey, look, for any Comfort Star system, you're going to need to pull a vacuum. You're going to need to pressure test it. So before, maybe they were doing it because it was a best practice, it was the right thing to do, but now they're going to have to, right? If they don't do it, then they'll probably void the warranty if there's a fire, if there's a problem, right? But the manufacturers are going to require your technicians to pull a vacuum, to pressure test it. Let's see, to purge with nitrogen while you're brazing, right? So all the common sense stuff. Maybe it's even all the stuff that you do with mini splits and VRF systems now, right? I know Mitsubishi, Samsung, all those guys require these things with their systems. But now moving forward, you're going to need to do it with your traditional residential stuff. Let's see. Equipment and servicing. Obviously, your scale's not going to change. Your gauges. If you've got like a digital gauge, I was talking to the guys over at Field Piece. They were saying if your gauges are newer than 7 years old, you're going to be able to just do a firmware upgrade, and you'll be able to upload the 454B and the R32 parameters into it, right? If it's older than 7 years old, you may need to buy a new one. Okay, and the field piece can only speak for field piece, but I would imagine it's the same for Yellow Jacket, for anybody else who makes this stuff. Anything that interacts with refrigerant, anything that actually touches the refrigerant, they're going to want to see, your contractors are going to want to just check that on the box somewhere it says A2L compliant. So vacuum pumps, evacuation machines, anything like that. It just, you're going to want them to see something that says A2L compliant. Now, with a lot of the vacuum pumps already, they are A2L compliant because they've been designed and built to pull all kinds of stuff out of systems. But they never really scored it and measured it and rated it and put it on the box because they didn't need to. But now with everybody moving to A2Ls, now everybody's doing something where it says A2L rated or A2L certified, that kind of thing. So look through the stuff that's in your shops, right? It should say A2L, compliant or stuff like that on there.
And we sell a few of those brands, so.
Yeah.
So and we sell Yellow Jacket, we sell Inficon.
Yeah, super cool. So it's not hard. I've been going on and looking just to kind of see, what does a contractor see? And it's right there. It's like one of the top 3 bullet points, when you go online, it's just A2L compliant. So pretty much the industry, all the tool manufacturers have moved on. Even Yellow Jacket has like A2L hoses.
Yeah.
So they've got a hose specifically to go onto an A2L cylinder.
Yeah.
I met with the reps yesterday, yeah.
Mm-hmm. Yep.
A bunch of this stuff. Fittings and hoses.
Hay que cambiar la pared.
So we'll talk a little bit about the cylinders in a minute, but right now, going over basically overview of XL41. We call it XL41. You guys may never call it that ever, but you're going to know 454B. So folks are going to come in and say, I need 454B or R32. Generally, for air conditioning, that's what it's going to be. Okay, so from the 30s out through the 90s, it's about those typical ones, CFCs, HFCs, HCFCs, but now we're getting into HFOs and HFO blends. So from here moving forward, HFOs and HFO blends are gonna be the future of how this thing goes, right? It's just the refrigerant breaks down so quickly. So let's see. Okay, all right. On the left, we've got an HFC, hydrofluorocarbon, okay? So the green ones are fluorine, the white ones are hydrogen, and then the black ones are carbon. Okay, that's what makes it an HFC. And go over to the right, it's still got the same fluorine and the same oxygen, hydrogen, the same fluorine, but now it's got 3 carbon molecules, and one of those carbon molecules has a double bond. So it's all chemistry, but that's called an olefinic bond. Okay, so that olefinic bond is really fragile, and when it gets out into the atmosphere and it interacts with oxygen, it breaks. And so that begins the chain reaction of breaking down this refrigerant. So this refrigerant that we're seeing here on the left is 1234YF, and it breaks down in the atmosphere in 11 days. It takes 14 days for a paper towel to start breaking down in the dump. So this stuff breaks down faster than a paper towel would, right? So that's why everyone's kind of loving these HFOs, because they're made to break down when they get into the atmosphere. Now, R32 doesn't break down as quickly, and that's why the GWP is above 4. Oh, that GWP number is right on the bottom. So 1234YF has a GWP of 4. So that sucker's going to just break apart. Now 32 breaks down longer. It takes longer to break down. So that's really where it's at. But again, when we go back to 410A, that stuff lives for 13 years, right? That stuff is up there and it's in there for a long time. So we're going from 13 years to 4 days, 11 days for some of the stuff. So that's why HFOs are coming in. That's why they're so popular with the government, with the world, and that's why they're working their way into the refrigerant business. That's the story with HFOs. Let's see. Opteon XL41 properties. Okay. Well, top line, we've talked about a little bit, composition. There's only two things in it. It's R32 and 1234YF. Now, the auto industry in the US has been using 1234YF since 2015, 2016-ish, right? So all the Mazdas, Toyotas, Ford, Chevys, everything that's newer than 2016 has 1234YF in it. Because those systems are like maybe a pound, and there's a lot of car accidents, right? So the auto industry switched over soon, really quickly, to these refrigerants that break down so quickly, right? So 1234YF replaces 134 directly, right? So the new systems are 134 or 1234YF, and now we're starting to see 1234YF being put into blends for other industries like HVAC or COMRAF or skating rinks, stuff like that. So we're starting to see that in the blend. But again, 454B only has two things in it, 32 and 1234YF. The GWP has gone down from 2,088 to 466. That's 22% of the original GWP. Let's see, capacity. So it has a little less capacity. And these next few numbers are all about the refrigerant itself. It is not about the equipment. It's not about the Comfort Star piece of equipment that's going to be sitting on your shelf. This has to do with the capacity of the refrigerant. And the capacity of the refrigerant is the ability for the refrigerant to move heat from one place to the next. How much heat can it carry? Okay, so 454B can carry 97% of the heat that 410A can carry. Okay, it's a little lower, but pretty similar, right? If I can carry 97 pounds instead of 100 pounds, it's a lot of, see, we're still in the ballpark, right? But now when it comes to efficiency, that next line is COP, that's the coefficient of performance. That efficiency, it's a little bit more efficient. And again, we're talking about the refrigerant, right? So what that means to a technician is the discharge pressure coming out of the compressor going into the condensing coil is closer to the suction pressure, right? Those pressures are closer together. So the compressor doesn't have to do as much work to get the compressor from the suction line out through the discharge line, right? So when those pressures are closer, they say it's more efficient. Okay, so it's more efficient, but it carries a little less capacity. So what happens is Rheem goes back to the shop, Comfort Star goes back to the shop, and they optimize their system so that their 14 SEER system from last year is still going to be a 14 SEER system. Maybe they're ramping the compressor up a couple more rotations, right? So whatever they're doing, they can tweak their system to make it work like the old one did, right? So you're still got the same compressor, same coil, that kind of thing, but they're going to optimize the system a little bit because of this increase in efficiency, decrease in capacity. They kind of go hand in hand. Now, when it comes to the next line down, pressure discharge pressure, it's under PSIA, and it's got a little bit less pressure. So across the board, when you look at all of our tables, you're looking at about a 30%, 30 PSI lower, 30 PSI reduction in discharge pressure. So people are like, oh my God, I bet it's more pressure, higher pressure. No, it's actually 30 PSI lower. And that's going to be in heat pump mode and in air conditioning mode. Now, the discharge temperature coming out of there is about 10 degrees higher, and that's in heat pump mode and air conditioning mode. So it is a little bit higher, but lower pressure. So what that means is the new Comfort Star heat pumps are going to be able to do more heating than the 2024 version, than the 410A versions were able to do. Okay, so your heat pumps are going to get a little bit better. But also at the same time, what people are going to see is if Johnny, because I love Johnny shows up and he puts a bunch of 454B into a 410A system and doesn't tell anybody, then the next guy that goes out there is going to start doing pressures and temperature readings on the system, and it's going to be screwy. There's going to be something off. There's some reason that the discharge temperature of coming out of the vents, the air temperature coming out of the vents, is not matching up with what he's seeing for the pressures, the temperatures in the system. Like the numbers aren't going to match. It's going to look wonky. Technically, the system will still run, but it's going to look wonky. And that's your technician is going to be your first indicator that maybe someone put the wrong refrigerant into the system, because they're similar, but it's going to be wonky. You know what I mean? Lower pressures, higher temperatures, that kind of thing.
It's going to be fun. Miami has a lot of Johnnies.
I'm telling you, I'm over in Texas, man. We got Johnny everywhere. But you know what? At least it's not, where was that? I was talking to some folks, I think they're in Arkansas. You don't even need to go to school. You just need to be able to buy a truck and you're in business.
Yeah.
The last bit on here is Glide. I don't know if you guys have heard of Glide. 410A has very little Glide, but the new refrigerants that are coming out do have some. So this has a little bit less than 2 degrees of Glide. And what that means is, are you guys familiar with Glide?
No.
Okay, so when the refrigerant comes out of the compressor, it goes into the condensing coil. 32 and 1234YF, they're going to boil off at different temperatures. So there's going to be a small section of the coil, right, like 6 to 8 inches or whatever, where 32 is going to be a gas and 1234YF is still going to be a liquid. But then by the end of that, like 6 to 8 inches, both are going to be a gas. Oh, sorry, both are going to be a liquid. You know what I mean? So it's they change phase at different temperatures, different pressures. Okay, so the difference between those two is the glide. You know what I mean? So that's something that no one had to deal with 410A. With XL41, it's built into the pressure temperature charts, all the PT charts, anything that Yellow Jacket and Field Piece are coming out with, it's all built into it. So the technician may not even be aware that's going on, but it's in that ballpark, right? So if they were to draw a table out on paper, they might be expecting like 187, but the temperature that's coming out is 189, and they may not be able to understand why, right? But that has to do with glide. Glide messes with the condensing coming out of the compressor, going to the condensing coil. That's where you see issues with glide. Now, 2 degrees is minimal, right? There's commercial refrigeration has ones that are out to like 9 degrees, 11 degrees, right? And that's where you really start having some screwy results if you're trying to do pressure temperatures readings on systems that might have had a leak. It's really hard to predict when you have a glide that big, but a glide of less than 2 degrees, manageable. This is it's like I said, it's very similar to 410A. Technicians really don't notice a difference, but glide is a part of the new refrigerants, but it's minimal. You doing? What's that? Duplicate slide. Okay, key characteristics. Why are people using XL41? It's got the lowest GWP of all the 410A-like alternatives. So when we went to Rheem and we said, okay, here are your options. Your options are R32 or 454B. 454B has lower GWP. The idea is we don't know if the EPA in the 2030s, if the EPA is going to come back and say, okay, the limit is now lower. The limit is now 500 GWP or lower, right? We don't know what the EPA is going to do, but if the EPA does come back and say, all right, guys, we're reducing down the limit down to 500, well, 454B fits that, right? It's still under 460, it's still 466. So it's got the lowest GWP, which means if Rheem and Trane and all those guys choose our product, then they're not going to have to redesign if the EPA reduces that limit back down again even further. Okay, so it's got the lowest GWP, which means it's the longevity of that design is gonna stick around a while. Similar operating.
R32,
Yes, sir.
right?
What's that?
It's not the same thing for R32.
No, R32 is in the 600s. It's like I can't remember what it is. I want to say it's
688,
is it 688?
something like that.
Yeah, something like that. So it's lower than, that's why they went with 700, because EPA went to 700 because both 32 and 454B fit under there. And so there was no reason to go to 750 or 800. They just called it at 700, which is good. 32 is a good product and it's used all over the world. So everyone is familiar with it. All the manufacturers are very familiar with it. So they really did have a choice if they were going to go 454B or 32.
And I heard 32 was going to be phased out by 2028.
Exactly.
No, I don't think they can do that because 32 is used everywhere. It's used in all kinds of stuff.
It's Mexican.
Yeah, I haven't heard anything like that.
Yeah.
Because they're just coming out with the limits now, as far as like all the manufacturers have to change to under 700 by January 1 of 2025. And that's the law, right? They're not even talking about revising that law at this time. So 2028 is way too soon for them to kind of knock it down again.
Right.
And 32 is used everywhere. 32 is a huge commodity. So I don't see that going away anytime soon.
So do you know which one the brands are going with more, like 454B or R32A? Like the popular
So
brands?
there's a little company called Daikin, and they own Goodman and Amana, and they are the only ones that are going with 32. Everybody else is going with 454B in North America, as far as like traditional residential stuff.
Yeah.
So, and that's because Daikin owns some factories that make 32, so they can't make it cheaper. You know what I mean? Like they can't get their refrigerant any cheaper than that. They make their own. So that's why they locked into 32. But everybody else who has to buy it anyway,
Yeah.
they're buying 454. They went with 454B. So Train, Carrier, Ream,
It's just
Nortec,
an extra
everybody.
thing to stock as distributors like ourselves, and it's gonna be an extra thing to stock as contractors, because they're gonna need 410A, need 407, they're gonna need 454, R32, they're gonna need all that in their truck now, because now everyone's gonna, well, not everyone, but
They don't make-
Yeah. I mean, I honestly, I don't, people laugh about it, but I see, refrigerant trailers becoming a thing. You know what I mean? Like, why not have one of those tiny little trailers that holds 6 or 7 different cylinders, put everything there and walk it into the garage and lock it up, I don't see why that's not going to be a part of the future.
You
But
can't
yeah, there's going to be a lot more stuff.
mix one with the other, right?
Say that again?
You cannot mix the gases, right?
Yeah, you don't want to mix the gases. And that's,
Do they work with the same oils?
yes.
So you can go to a Daikin that had a freon leak and it's empty, and you can vacuum it out and you don't have to change the oil in the compressor. You could dump 454B in there, right? And it'll work fine.
No, that's definitely a scenario that you want to never do.
He's
Right,
he's
so-
a little Johnny here at A&R.
so so it's kind of like, I was trying to explain it to some folks, right? It's kind of like if you've got a 1960s Mustang, right? You're going to put 1960s parts into that 1960s Mustang. You're not going to put 2024 parts into that old Mustang. So same kind of thing. You're going to put the new refrigerant into the new systems. If you've got an old system that uses 410A or even 22 or 32.
No, I'm not talking about old systems. I'm talking about the new systems. A Daikin system, for example, that uses that R32. If that system has a freon leak and it has no more gas in it, can they refill it with 454B?
No. Yeah, no, they can't, because the performance of 32 is different than
Yeah,
Then
so the
410A,
expansion
right?
valve and all that would work different because it's going to be for the other guys.
Yeah, so the deal is, and you guys are going to see that. So like Daikin has to put in a new size of compressor, new size coils, right? Their coils need to be deeper. All kinds of stuff is different with 32. And that's why a lot of the OEMs went with 454B, because they have these contracts that last like 10 years. And whoever they're buying their coils from, they're not just going to like retool and remake millions of coils. They're not going to do that, right? So with 454B, it's the same compressors, just tweaked to a different speed, same coils, same expansion valves, pretty much all the same components. But when you go to 32, it's new compressors, new coils, new valves, all that stuff. So if you were to put 454B into a system made for 32, it wouldn't work right. It performs different. You know what I mean?
so Chris, not
It-
to stay off this or stop you from keep going forward, but you had mentioned if someone puts the wrong refrigerant in the unit, it will technically work. What were you talking about then? Were you talking 454 with 410A, or what were you?
Yeah.
Okay.
Yeah, because we see that, being a more common thing.
Yeah.
You know what I mean? Like that's because 454B is going to be so prevalent out there.
Yeah.
80% of the market is going with 454B. So, you're going to see stuff like that probably happen. And the two really do work very similarly. So Johnny puts in the wrong refrigerant and walks off the job. He's going to think he did a great job. And the callback's going to come a couple days later when the homeowner's like, I'm not sure. Something's not right. It's not, it's not as cool as I thought as it used to be, you know, the air coming out. So
Right.
the callback's going to be a subtle weirdo one. But if
Right.
you were to do it with 32, it just wouldn't, you would know immediately that it's not working.
Okay.
Now, 32 does use a different oil. 32 uses its own different oil. It needs to have a lower viscosity, right? It's got to be thinner because 32 doesn't, it burns hotter. And so there's something about it. 32 runs a higher temperature.
Right.
And so it needs a different viscosity of the oil. It's still POE, but it's like POE 32, while everyone else is using like 36 or something like that. But it's the viscosity that's different. So it's the same thing from 410A to 454B. That's the same oil, viscosity and everything. But 32 just has a few different features.
Cool.
I have a question.
Yeah.
These regulations set in stone in here, because the country is going into a crazy future. And for example, right now, this thing going on with appliances in Congress. You understand what I'm saying? The question?
No, I hear the question. I understood what you were saying about the country going crazy and appliances in Congress, but I didn't understand the question.
This new mandate on these refrigerants is going to set in stone. It's going to happen, or is it a?
Oh yeah. Yeah, this stuff is set in stone. Yeah, this happens. So the manufacturers are already starting to transition over. And they have to be 100% transitioned over by January.
21st, yeah.
Right. So like Train is already taking orders. Carrier's already taken orders. JCI is already taken orders. So you're going to start seeing equipment on the shelves. I don't know what Ream's timeline is, but they'll tell you when they're going to have it out there. But no, this transition's happening this year.
Got it. Thank you.
Yeah. Set in stone. And yes, this country is going crazy. I saw that. It's transcribing everything. And so I'm listening to you and you're like, you know how the country is going crazy right now? And I'm like, I know, bro. I know. I get it. Near performance match. Yeah. So that's kind of that third point on there is kind of what I was saying. It's it works so similarly to 410A that OEMs just picked it because, you know, they get to keep the same contract, same components. And then pretty much the biggest thing on it too is if everything still looks the same, then the technicians don't need to go through a whole lot of training. They're going to have to go through some, but imagine if there were new compressors, you know, new temperatures, new pressures, like everything in there was different. Y'all would be doing a ton of training, right? But because they're going to a refrigerant that acts very similar to 410A, we don't have to do that. So that's why a lot of these manufacturers went with this also. It's an added plus. XL41 in use. Okay. So essentially these residential systems are going to have somewhere between 6 pounds and like 10 pounds of refrigerant in them. Okay. That amount of refrigerant in there means that it needs to have those sensors. And so you guys are going to hear more and more about these sensors on the coils and in the air handlers. And even with a furnace, right, that coil is still going to have those sensors. And so what's going to happen is when that sensor triggers, it's going to send a signal to turn the blower on. And it's going to turn the blower on and it's going to get the refrigerant to a more open area rather than inside the air handler. But everything that they're doing, those sensors, the mitigation technology, all the stickers that they're putting on, all the new training and regulations, it's all about preventing. It's all about prevention. So it may sound like we're telling you two different things. It may sound like we're saying it's flammable, but not that flammable. But then the OEMs are going to come out and they're going to say, you have no, like this is really a problem. But it's all about trying to prevent there ever being a flame. Hopefully your technicians never ever see a flame, right? And so everybody, all the design work that's being done is to prevent a flame from happening. So it may look like overkill, but we're really trying to make sure that there's no issues whatsoever. To date, in all the decades that people have been using 32, there's never been a death related to 32, right? And that's all over the world. Europe's been doing it for years, Asia even longer. And this isn't like a flammability, gonna kill you type situation, right? But it's because the OEMs put on sensors and stickers and labels and everybody's doing all this training and stuff like that. So Let's see. Can I use it as a drop-in for 410A? No. And that's the number one question that we get. So expect that. That's the answer. Can I use it as a drop-in? No. Is there going to be a drop-in for 410A is the second question. No, there's not going to be a replacement or a drop-in for 410A because 410A is not getting phased out. They're not phasing out 410A. They're just telling the manufacturers they can't make new equipment with it. So if you've got a 410A system and you're putting it in November, December of this year, the technician's going to be able to service it, do repairs on it for the life of the equipment, right? If he can make that thing last 20 years, he's going to be able to. 410A, he's going to have access to. He'll have access to the compressors, to the coils, all that stuff. Everybody wants to be able to service existing equipment. No one is making existing equipment get pulled out and replaced. That's not what's happening. And a lot of technicians ask that. So they're going to ask if there's a replacement like MO99. No, there's not going to be anything like that. You're going to be able to get 410A for the long term. They should feel confident that they can install a system this year and service it for the next 15 years. They can still sell it to their customers. But January 1, they're just going to be installing a system that has 454B in it instead, right? So that's the only change is that what's being sold.
And we could sell 410A next year systems.
Yeah. Mm-hmm. Yeah, there's that sell-through thing, right?
Yeah, exactly. We all of next year, I don't know if you guys know, but all of next year, we will be able to sell 410A without restrictions, without violation, anything like that. It's in 2026 is when we can only do component change out. So you could change out a condenser or change out an air handler, but you can't do both. Which in the long run, who's going to monitor that and tell you who's stopping little Johnny to invoice a condenser today and invoice an air handler next week? But we will, and your contractors, our contractors will be able to sell 410A and install brand new units of 410A next year. Now, how many 410As will we have in stock? And 454B, that's up to A&R and things like that. So.
Yeah, so it's a sell-through thing, right? So Rheem can make brand new systems up until December 31st with 410A. So if A&R says we're stocking up, man, they go and buy a warehouse and they load it with 15,000 of 410A systems. They can sell those ones that they stockpiled. They can sell those all 2025, no issue whatsoever. You know what I mean? So, but it has to be purchased. No. I mean, if it's made, you guys can sell it. Yeah.
Yeah, as long as it's imported before January 1st.
Yeah.
So it needs to be imported before January 1st.
Mm-hmm.
That's the only restriction for Comfort Star.
Is Comfort Star an Asian product like Medea?
Yeah, it's manufactured and assembled in China.
Yeah, super cool. Medea is a good company. They do a lot of stuff. I don't know if Comfort Star is Medea, but that's a good product.
Oh, yeah. No, we've asked, but the boss lady tells us if she tells us she's got to kill us. So we don't know. No, from our understanding, they buy third party.
You got a rough boss, bro.
China.
That's Miami. I don't know about Miami, dude.
No, Comfort
I'd rather
Star
go to Albuquerque. But yeah, it just needs to be imported and stuff like that. But and Medea is one of those companies that's also going to 454B. Again, like it's a huge majority. So all of Medea's mini splits, all of their residential stuff, all of that's going. Let's see. Yeah, and really the big thing to remember, equipment that's made for A2Ls is going to have all of these new safety features that A1 systems don't have. So that's why you're not going to want to put an A2L refrigerant into an A1 system because it's technically not built for it. It doesn't have the safety features. And that being the case, like heaven forbid there's a fire or something, that's a big problem, right? And we want to avoid that at all times. So don't put an A2L into a system that's made for an A1. Let's talk about the cylinders. So the new cylinders, all these A2L cylinders, even R32, they're going to be gray like this, and they're going to have a red band around the top. So the one on the far left is a 90-pound cylinder, right? So that's refillable. That's got 90 pounds in there. The middle one is a recovery cylinder. The recovery cylinders for A2Ls are also going to have that red on top. And then this is the DAC, right? This is the 20-pound cylinder that we have. And you guys are going to see that it's going to have that red band on there. We also sell an R32. It's also going to have that red band, same look on there. Now, there's a couple things that are different. I thought I had a slide in here, but it looks like I missed it. This slide here shows you the rupture as the pressure relief valve. That's a spring-loaded pressure relief valve instead of a rupture disc. So that spring-loaded pressure relief valve is just going to burp out whatever pressure is in there to get it back under a certain level, right? So that level is 500 PSI. Okay, the cylinder is made for 1,000 PSI, and when we fill it at 300 PSI. Okay, but that thing's going to burp at 500 PSI roughly when the truck gets to the truck that it's in or whatever its surrounding is, it gets to 140 degrees. If that cylinder, the contents heat up to 140 degrees, it's going to reach that 500 PSI and it's going to burp out vapor to reduce that pressure. Okay, as opposed to blowing the rupture disc and blowing the whole contents into the truck. Okay, so that's going to be something that's unique to A2L refrigerants there. Now, another thing that, and I missed, I should have had that slide on here, but I missed it. The valves up at the top is going to be left-handed threads. Okay, so that's going to be for that 90-pound cylinder and for that that smaller cylinder, right, the 20-pounder. It's going to have left-handed threads on there. And so, like I was saying, Field Piece, sorry, it's either Field Piece or Yellow Jacket, they've got a hose that is left-handed threads, but for the most part, all the other distributors are carrying an A2L adapter. And that A2L adapter just turns it from a left-handed thread to a right-handed thread. And it sounds dumb, but we all know Johnny, and this is basically like a child-proof lid on medicine, okay? Essentially, here's the idea. Johnny gets out of school, his job when he gets hired on, it's going to be to go out and clean coils. That's his job. Okay, he is running out to a job, and there's more work than there is technicians, right? And so Johnny is asked, hey, look, they're a little low on charge. He thinks they're a little low on charge. He could just do it right now. And so his boss says, yeah, just top it off. He goes over, grabs the wrong jug, puts on his gauges or tries to. If he doesn't know anything about what's going on with A2Ls, he's going to call back and he's going to say, hey, my gauges don't work. I don't mean to sound stupid, but I don't know why my gauges don't work. And that's going to start the conversation. What are you doing? What kind of cylinder are you using? Right? So having the left-handed threads is really just a safety precaution because maybe little Johnny didn't get the training, but this is going to start the conversation to get that training going. Look, this is an A2L. You don't want to put it into that system. You want to put in the pink cylinder. You know what I mean? So that's the idea with that. But you guys are, it's like the if you guys are familiar with the mini split adapters, it's similar to that. It kind of looks just like it, except it's for A2L cylinders.
I have a question on the pressure valve.
Yes, sir.
I'm reading that a car with a closed windows in the summer reached 160 or 170 degrees inside.
Yeah.
Is that going to ignite the valve?
It's not going to ignite it. No, it'll get it to spring out, burp out. Yeah.
And what's going to happen?
I think you
It's
said
gonna
140,
leak
right, Chris? 140 was
Yeah,
the
but
fix?
it's
Yeah,
not
about 140 degrees. Yeah. If you look at our PT charts, that's where you start to see like at around 140 to 145 is when it reaches 500 PSI.
And it's not gonna release gas, it's gonna release pressure from inside the
No,
tank.
it's gonna release gas, but it's gonna burp it out. It's not like a pressure. So what he was explaining, that valve, when it reaches 500 PSI, it's gonna release just enough so that it's under 500 PSI, but it's only gonna burp it out. It's not like a regular pressure release valve where it empties out the entire tank.
So a 25-pound tank, if it's 140 degrees, probably won't be 25 pounds by the end of the trip.
Maybe not. Yeah.
Right.
The problem is when the guy turns on a cigarette in the morning.
Are you going to be able to use
You
that
might
cylinder?
walk out without eyelashes. Not a problem, but it'll be all right.
Are you going to be able to use that cylinder even though the valve is pop out?
Yes.
Yeah, it sucks back in. Yep.
Oh, okay.
Yeah, that's not an issue. But then when it's done, right, when you've killed that cylinder, you're still going to need to puncture it, right? So you're gonna pull out whatever's left in there, half a pound, a quarter of a pound, and then you're still going to puncture that DAC before you toss it out. So this is where we talk a little bit about it. And you know what? Look at that picture over on the far right when it's on that, when they're on the rack. If you look back at this pressure relief valve, you're going to want that at the 12 o'clock position. You're going to want that on the upper side. Because if it's on the lower side, right, it's just going to blow liquid out and you're going to lose a lot more refrigerant. You know what I mean? So that's going to be part of it. If they're going to put it in a rack, they're going to want that pressure relief valve up.
I see a lot of Johnnies coming back for warranties.
Yep.
And what is, how can CHEMOURS know if we claim something like that? You know, if someone comes up and says, oh, I bought a tank, but it's half empty. And it might have been because of that, because they were in a van over 140 degrees.
I'm telling you, what's
But is there a way to tell, like, hey, this has been activated, the valve has been activated, and that's why, or?
oh, that's a great question. No, I've never heard of that. And that's a great question. No, I don't know. I'll find out about that because that'd
be
That
cool
makes
if
sense.
there's a certain way to tell, hey, this valve has been activated, and that's why you're less than 25 pounds. You know, you probably are in a van over 140, whatever. You know, we can.
yeah,
I can't claim that. I'm not gonna claim this because you had it inside a store. You know, whatever.
yeah, that makes a lot of sense.
Los locos son los burros reciclando por el mismo tanque vacío para que tú veas cómo van a salir. Y se le pasó de una para que tú veas.
Let's see.
Parecen a pinche
Questions. We're at the end. Is there anything that we didn't talk about? I'm not sure if there's something we missed.
No, I think
I think we've asked.
I think you nailed. No, I think that's it, Chris. We really appreciate your time and thank you for. I know after so many months of trying to get this hooked up, so
I
we
know.
really appreciate your time and very informational. And I think everyone here is leaving with more information than they had coming in. So we really appreciate it.
Really
Super
appreciate
cool.
it, man. Thank
No
you.
problem at all.